There is a lake in New Zealand that was once so full of life, the Maori called it the place where the water breathes. It sat at the center of the North Island, ringed by mountains that caught the clouds. The water was clear, the way very old water gets clear, not empty, but deep, layered with organisms that had been refining themselves for millions of years in complete isolation from the rest of the world. New Zealand had been cut off from every other landmass since before the dinosaurs disappeared. The fish that lived in that lake had never competed with anything from the outside. They had never needed to. They had built entire ecosystems based on that fact. Then, in 1869, a British colonist carried a wooden crate of brown trout across the ocean and tipped it into the water. Within 30 years, more than 200 species of native fish were functionally gone from that lake. Nobody set out to destroy anything. Nobody stood on the shore in 1869 and said, "Let us see what happens when we detonate this ecosystem." They thought they were improving it. They thought they were bringing progress to a place that did not yet have the right fish. That is the thing that makes this story so uncomfortable. It was not malice. It was confidence. The absolute, bone-deep confidence that what they were doing was correct. And that confidence cost an entire world. Before we get into what happened at Lake Taupo and why it still matters to every living system on the planet today, make sure you are subscribed. This channel covers the real costs behind the decisions that shape our world, the ecological, the economic, and the human ones. Hit the bell so you do not miss what is coming next. Now let us get into it. Lake Taupo sits inside the caldera of a supervolcano that last erupted in 232 AD, with enough force to alter global temperatures. When Polynesian voyagers arrived in New Zealand roughly 800 years ago, they found a lake that was, by any modern measure, staggering. It covered more than 600 square kilometers. It drained a watershed that fed some of the most biologically productive rivers on Earth, including the Waikato, which at the time of European contact was one of the longest river systems in the country. The fish that lived in that system were not the fish Europeans recognized. New Zealand's freshwater fish fauna is one of the most unusual in the world, precisely because of how long the island spent in isolation. Gondwana broke apart roughly 80 million years ago, and New Zealand drifted away from Australia well before that. What that meant in practice was that most of the freshwater fish families that spread across the rest of the world simply never arrived in New Zealand. The country developed its own freshwater communities from a very small founding set, and those communities became extraordinarily specialized over tens of millions of years. The dominant native fish in the Taupo system were galaxiids. These are small, scaleless fish that look superficially like trout, but are not related to trout in any meaningful evolutionary sense. They had been in New Zealand so long that the country held more species of galaxiids than anywhere else on Earth. They were the backbone of freshwater ecosystems that extended from the mountains all the way to the coast. Some of them were diadromous, meaning they split their lives between fresh and salt water, migrating as juveniles from the sea back up rivers to spawn. Some were landlocked in lakes. Some had evolved to exploit extremely cold, oxygen-poor waters high in the mountains where nothing else could survive. The Maori relationship with these fish was precise and intimate in the way that only centuries of close observation produces. Different species were harvested at different times of year using different methods. The whitebait that New Zealanders still harvest today, though in drastically reduced numbers, are largely the juvenile migratory phase of galaxiids. The Maori managed their harvests carefully. They had sustained populations that the ecosystem had sustained for millions of years. That is the world that existed before the crate arrived. The men who introduced brown trout to New Zealand were not random actors. They belonged to acclimatization societies, formal organizations with charters and committees and annual reports, whose explicit purpose was to improve the natural environments of the colonies by supplementing them with familiar European species. The ideology behind these societies was not fringe. It was mainstream Victorian thinking about what nature was for and what improvement meant. Nature, in this view, was a resource that existed to serve human purposes. A river without salmon in it was a river going to waste. A lake without trout was a lake that had not yet been properly organized. The acclimatization societies operated across the British Empire. They introduced rabbits to Australia, deer to New Zealand, and dozens of freshwater fish species to waterways around the world. They kept careful records. They celebrated their successes in their annual reports. The introduction of brown trout to the Waikato system was not an accident or a rogue act. It was a planned, organized, officially sanctioned improvement. The first successful establishment of brown trout in New Zealand happened in 1867, with fish transported from Tasmania. By 1869, trout were established in several river systems on the North Island. By the 1880s, the introduction program was considered one of the great successes of colonial natural resource management. The fishing in the Taupo system was being described in British sporting publications as among the finest in the world. It was among the finest in the world. That part was true. The problem was what made it that way. Brown trout are predators. They are extremely effective predators, built by millions of years of evolution in complex European river systems, where they competed with dozens of other species, and where their prey had spent an equivalent amount of time evolving evasion strategies. They are fast. They have excellent vision. They can hold position in current with almost no energy expenditure and strike at prey with extraordinary precision. In European rivers, they are kept in check by a web of ecological relationships, by parasites, by competitors, by the fact that their prey evolved alongside them and developed countermeasures. In New Zealand, they entered a system where nothing had ever seen them before. The native galaxiids had never needed to develop anti-trout behavior. They did not school in the ways that many prey fish school when predators are present. They did not seek deep cover in the specific ways that trout pursuit selects for. They were, in evolutionary terms, defenseless against an adversary they had never encountered in 60 million years of isolation. The trout did not merely compete with them, they ate them. In some river reaches, the native fish populations collapsed within a single generation. This is the part of the story that is important to understand precisely because it gets simplified in ways that miss the mechanism. People hear that trout outcompeted native fish, and they imagine a kind of fair contest that the trout won. That is not what happened. There is a concept in ecology called naive prey, referring to species that have not evolved in the presence of a particular predator, and therefore have not developed the behavioral and physiological responses that allow them to survive contact with that predator. The galaxiids were naive prey. They were not outcompeted. They were eaten before they could reproduce. The difference matters because outcompetition implies that the native species could have adapted given time. Predation on naive prey at the scale that happened in the Taupo system does not leave time for adaptation. The 200 species figure that appears in the title of this story requires some context, because not all of those species disappeared from every waterway in New Zealand simultaneously. New Zealand's freshwater fish fauna contains roughly 70 recognized native species, many of them galaxiids. The broader collapse figure of around 200 species of freshwater organisms includes invertebrates, insects, crustaceans, and other animals that depended on galaxiid populations as a food source, or that competed with trout in different ways, or that were affected by the cascading changes in water chemistry and sediment dynamics that followed the ecological reorganization of the lake and river systems. The collapse was not of a single trophic level. It cascaded up and down the food web simultaneously. By the time New Zealand fisheries scientists began systematically documenting native fish populations in the mid-20th century, several galaxiid species that had been widespread in the pre-trout era were either extinct or restricted to tiny refugia, usually in small streams above waterfalls that trout could not ascend. The waterfall itself became a kind of accidental conservation boundary. Everything below the waterfall was trout country. Everything above it was the last surviving fragment of a pre-contact world. Some of those fragments still exist today. Ecologists who study them describe them as windows into what New Zealand's freshwater systems looked like before 1867. They are small. They are fragile. and they are almost completely unknown to the general public, who think of trout as a native fish. That last point is worth dwelling on. Ask most New Zealanders today what fish live in their rivers, and the first answer will be trout. Ask them about the native fish, and many will mention whitebait with some vague awareness that it is important. But the full picture of what existed before colonization is not part of the general cultural vocabulary. The trout has been in the rivers long enough now that it has become, in lived cultural experience, the default fish. The erasure was so complete that even the memory of what was erased has largely been erased. This is not unique to New Zealand. It is one of the consistent features of ecological collapse on island systems. The baseline shifts. Each generation inherits a landscape already impoverished relative to the one before, and takes the impoverished version as the norm. Ecologists call this shifting baseline syndrome, first formally described by fisheries scientist Daniel Pauly in 1995. New Zealand is simply one of the best documented cases. The brown trout were not the only introduction that damaged New Zealand's freshwater systems, but they were among the most consequential. Rainbow trout followed. Perch were introduced. Catfish arrived. Each introduction added pressure. But the brown trout had a special status because they were introduced early, established quickly, and occupied the top of the food web in a way that reorganized everything below them. What the trout did to the fish, they also did, indirectly, to the river systems themselves. Galaxiids played specific roles in nutrient cycling, in sediment dynamics, in the processing of organic material. When their populations collapsed, the rivers began to change. The loss of certain invertebrate species that the galaxiids had kept in check led to changes in how aquatic vegetation grew. Changes in vegetation affected how water moved through river systems. Changes in water movement affected how sediments settled and how banks eroded. The effects ramified outward across the entire watershed in ways that were difficult to trace precisely because nobody was watching systematically when it happened. The trout also brought something else with them, something less often discussed in the ecological literature, but at least as important in terms of long-term consequences. They brought a particular vision of what freshwater systems were for. The acclimatization societies did not just introduce fish, they introduced a legal and cultural framework for managing freshwater as a sport fishing resource. That framework persisted, and it persisted with remarkable durability. For most of the 20th century, the management of New Zealand's lakes and rivers was dominated by the needs of the recreational trout fishery. Trout were legally protected as a game fish. The introduction of native fish to waters containing trout was actively discouraged or prohibited in some contexts because of concerns that native fish would compete with trout for food. The management framework that was designed to protect trout had the effect of actively suppressing the recovery of native species, even in cases where recovery might have been possible. This is the part of the story that connects most directly to the kinds of questions this channel exists to ask, because it is about who pays the costs of particular visions of the world. The recreational trout fishery in New Zealand is not a small or marginal thing. It generates hundreds of millions of dollars annually in tourism revenue. It supports a significant guiding industry. It is deeply embedded in the national identity in a way that is particularly strong among certain social groups, particularly men of European descent, of a particular generation and cultural background. The imagery of a man in waders standing in a clear river surrounded by mountains is part of how New Zealand sells itself to the world. The cost of maintaining that image has been paid by the native freshwater ecosystems, by the people whose food systems depended on those ecosystems, and by the broader public interest in biodiversity that nobody priced into the 1,869 decision to open that crate. The Maori relationship to freshwater fish was not primarily recreational. It was dietary, cultural, and spiritual. The whitebait harvest was not a sport. It was food. The galaxiids that the colonists replaced with trout were not absent from Maori cultural and economic life. They were central to it. The substitution of a European sport fish for a Maori food fish was not a neutral ecological event. It was a specific redistribution of whose relationship to the water mattered and whose did not. This is not a point that requires ideological framing to make. It is simply a description of what happened. The acclimatization societies were working within an explicit framework that valued European sport fishing over Maori subsistence practices. That framework shaped what got introduced, when, where, and how it was managed afterward. The ecological outcomes and the cultural outcomes were not separate. They were the same event seen from different angles. The economic dimension of this history becomes more specific when you look at what happened to communities whose food security depended on the freshwater fishery. Some of those communities were Maori. Some were also European settlers in rural areas who had come to rely on native freshwater species as a significant dietary resource. When the Galaxiid populations collapsed, those communities lost a food source. They did not receive compensation. The acclimatization societies did not conduct an accounting of what they were taking away when they introduced trout. They were not required to. The legal and cultural framework of colonial New Zealand did not demand that kind of accounting. The connection to low-cost living, to the specific concern of this channel, is this. When ecological systems that provide free food, clean water, and natural pest control are degraded, the costs that were previously zero become non-zero. The whitebait that Maori families caught in the rivers for centuries was not a luxury. It was nutrition that did not need to be purchased. When the populations of whitebait phase galaxiids collapsed under pressure from trout, the people who had depended on whitebait faced a choice between paying for the nutrition they used to harvest freely or doing without. Neither option is what they had before. New Zealand whitebait today sells for prices that range between 50 and 100 New Zealand dollars per kilogram in good years. It is a luxury food. It is served in restaurants. It is spoken of in the same breath as truffle and saffron. The transformation of a subsistence food into a luxury commodity is a precise economic description of what happens when ecological abundance is destroyed and replaced by scarcity. The people who created the scarcity did not bear the cost. The people who had depended on the abundance did. This pattern is not unique to New Zealand. It appears wherever colonial ecological interventions destroyed subsistence economies to make way for market economies. The fish that got replaced by trout were ecologically free to harvest in ways that trout, which required stocking programs, management infrastructure, and access to licensed fishing areas, were not. The substitution moved the economy of freshwater resources from one where access was roughly equal and cost was roughly zero, toward one where access was stratified and cost was significant. The people with leisure, time, and money to invest in fishing licenses and equipment gained. The people who had relied on the rivers as a food source lost. The thing about these substitutions is that they look invisible once they have been in place long enough. If you grow up in a New Zealand where trout fishing is what rivers are for, the question of what those rivers used to provide does not naturally present itself. The loss is complete enough that it does not register as loss. It registers as the normal state of things. Lake Taupo today is managed as a premier trout fishery. The fishing is regulated by the Taupo Fishing District, a jurisdiction that exists specifically to manage the sport fishery. The lake is internationally famous for its rainbow trout in particular, a second species introduced in the early 20th century. Anglers travel from around the world to fish it. The economic activity generated by that tourism is real and significant. The native fish are present in the lake's tributaries above waterfalls in some places, absent from the main lake and its accessible tributaries in others, and almost completely absent from public awareness. The New Zealand government has programs to protect native freshwater fish. Conservation groups work on the problem, but the baseline they are working against is the trout-dominated system, and reversing that is an enormously difficult ecological and political project. The difficulty is political as much as ecological, because the people who benefit from the trout fishery are organized, vocal, and politically effective. They have been managing this resource according to their interests for over 150 years. They have built institutions, legal frameworks, economic infrastructure, and cultural identity around it. The people who bear the costs of the original decision are diffuse, less organized politically, and working against a baseline shift so complete that many members of the general public do not even know there is a loss to mourn. This pattern repeats across the history of environmental management. With the regularity of a natural law, the beneficiaries of an ecological change are concentrated and motivated. The costs fall on people who are diffuse and less powerful. The institutions manage for the beneficiaries. The cost-bearers struggle to be heard. The science on what happened in New Zealand's freshwater systems is extensive. Researchers have studied it for decades precisely because the isolation that made these ecosystems unique also makes them a precise laboratory for understanding what happens when that isolation is broken. What they have found is not encouraging. The prognosis for New Zealand's native freshwater fish is genuinely bleak in many parts of the country. The most recent assessments found that more than 3/4 of freshwater fish species in New Zealand are classified as threatened or at risk of extinction. This is not a historical loss. This is ongoing. Species that were widespread within living memory are now restricted to fragments. Some of those fragments are losing ground. The extinctions that began in 1867 are continuing in 2026. The mechanisms operating today are not identical to those that operated in the 19th century. Climate change is now adding to the pressure in ways the acclimatization societies could not have anticipated. Warmer water temperatures favor trout over some native species that prefer colder water. Drought is increasing the fragmentation of river systems, isolating populations of native fish in ways that make genetic rescue difficult. Land use change continues to degrade the habitat that native species require. The trout are still there. The cascading effects they triggered are still running. The question this story eventually forces is the same question that underlies almost every large-scale environmental decision. Who decides what a place is for? Who gets to define what counts as improvement? And who pays the cost when that definition is wrong? In 1869, those questions were not asked. The men who tipped trout into the Waikato system were sure they knew the answers. They were wrong in ways that have proven essentially irreversible on any timescale that matters to human beings. The 200 species that were gone by the end of the 19th century are not coming back. The ecosystems that sustained them for millions of years have been reorganized into something else, something productive for a specific group of people with specific interests, something foreign to the landscape in which it now operates, and something that continues to expand its footprint while the native systems contract. The thing about irreversibility is that it does not announce itself. It arrives gradually, species by species, population by population, watershed by watershed, until one day an ecologist sits down to add up what is left and finds that the math does not work anymore, that there are not enough individuals of a species spread across enough locations to sustain a viable population, that the last refugium above the last accessible waterfall has been stocked, and that the extinction that began with a crate of brown trout in 1869 has finally completed itself. That has not happened yet for all of the species affected by the original introduction. It has happened for some. For others, the question is still open. What happens next depends on decisions being made right now. In government offices and regional councils and university research departments and conservation organizations, about how much the surviving fragments of pre-contact New Zealand freshwater ecosystems are worth protecting, and what price people are willing to pay in political capital, in regulatory conflict with the sport fishing industry, in the grinding work of habitat restoration, to prevent the extinctions that are still preventable from completing themselves. Those decisions are being made in a world where the baseline has shifted so completely that most of the people who will be affected by them do not know what has been lost, or that there was ever anything different to lose. The Maori term for the phenomenon of a place losing its vitality, its spiritual and ecological life force, is a word that does not translate cleanly into English, but carries the sense of a landscape that has been unmade. The rivers that run from the Taupo caldera to the sea today are not unmade. They contain fish. They move through a landscape of considerable beauty. But they are not what they were. They are a reorganized thing, running in old channels, carrying the water of a watershed whose biological community was altered in less than a human lifetime by a decision made with complete confidence and essentially no understanding of what it would cost. The cost is still being paid. It is paid every time a galaxiid population blinks out in a reach above a waterfall that used to be a refugium but is not anymore. It is paid every time a community that depended on whitebait as a food source goes to the supermarket instead because the rivers near them no longer hold enough fish to harvest. It is paid in the absence of species that existed for tens of millions of years and were gone before they were properly described. The specific drama of Lake Taupo is this: the lake that sits inside a supervolcano caldera that the Maori knew as the place where the water breathes, that contained one of the most isolated and ancient freshwater communities on Earth, is now internationally famous as a trout fishery. The trout are magnificent. They are large and strong and beautifully adapted to the cold, clear water. They attract anglers from around the world who spend money and generate employment and contribute to an economy that is genuinely important to the region. And they are standing where something else used to stand, in water that was organized by millions of years of evolution to hold something entirely different. And the something different is largely gone, and most of the people fishing in the lake today do not know it was ever there. That is the full shape of the story, not malice, confidence. The confidence that a familiar thing is better than an unfamiliar thing, that a European fish is more valuable than a New Zealand fish, that improvement means making a place more like the place you came from. The confidence that allowed an entire ecosystem to be replaced without asking whether replacement was a good idea, without counting what was being lost, without even registering that loss as a category worth considering. In the century and a half since the trout went into the water, that kind of confidence has not disappeared from environmental management. It has changed its vocabulary. The acclimatization societies spoke of improvement and progress. The frameworks that replaced them speak of ecosystem services and cost-benefit analysis and stakeholder engagement. But the fundamental dynamic, where the people who hold power define what a place is for and impose that definition at cost to the people and species that do not hold power, has not changed as much as the vocabulary suggests. The galaxiids in the streams above the waterfalls are still there. That is the remarkable thing. After 150 years of pressure from trout below and habitat degradation from land use above, and now the changing climate pressing down from everywhere at once, some of them are still there, small populations, fragile refugia. But there, whether they will still be there in another 150 years, depends on whether the people making decisions about freshwater management in New Zealand right now decide that those fish matter, that they have a value that is not captured by the trout fishing license fees and tourism revenue and guiding industry employment that the current system generates. That an ecosystem which took 60 million years to assemble has a claim on the future that a sport fishery, however economically productive and culturally embedded, does not automatically override. That is not a purely ecological question. It is not a purely economic question. It is a question about what we owe to the world we inherited and the world we will leave behind, about whether the things that were here before us have a right to persist, about whether confidence is enough justification for irreversible action. The men who carried that crate to the water's edge in 1869 were confident. They had no doubt at all. The fish went in, the native species started disappearing, and within 30 years the world that had existed there for 60 million years was gone. They were very sure about what they were doing. That is, in the end, the part of the story that stays with you.